Why are the two triangles congruent shown? Do we all agree it's SAS? There's two sides marked and the angle smack dab between. So that's ASA. Can you give me a congruent statement? Good. Pick any order you want for the first triangle. He picked KJL, but could you pick any way? Sure. But now what matters is you match stuff perfectly. What would go in the first spot? O. What would go in the second spot? N. And what goes in the third spot? So my two triangles that are shown here are congruent by SAS. Now, this is what's new today then. Knowing that the triangles are congruent, right? They're congruent. If they're congruent, wouldn't it be true that every piece about them is congruent? Even besides the ones marked? If those triangles are congruent, then it has 6 things congruent. 3 sets of sides, 3 sets of angles. Well, I only gave you 3 sets. So list the other things that would be congruent, even though technically they're not marked, because we said they're congruent. So give me an example of what I'm talking about, somebody. 'Cause I know there's some people out there that understands. What's something that we know is congruent, even if it's not marked? Casey?
Angle K is congruent to angle O.
Angle K will be congruent to angle O. Do we agree that those are corresponding positions? And are these on congruent triangles? So they have to be congruent. What else would be congruent even if it's not marked, just because we know the triangles are congruent? Megan? Angle N would be congruent to angle J. Oh wait, what? Yeah, J, sorry. Next one, Jaden. Perfect. We can say these 3 things are congruent. Not because they make us say that the triangles are congruent, but because the triangles are congruent, those pieces are congruent. That's the first theorem, okay? Our first theorem allows us to say, and here it is, corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. That is a long phrase to write on a proof. So we can shortcut it. Cpctc. We can just write Cpctc to say this stuff that we just wrote down there. So we do a proof. Think about how this is going to look. We're going to do a proof. We're going to do a proof. We're going to get the triangles are congruent by SAS, SSS, something. And then boom, right after it, we can use Cpctc to say something like these. Are we going to want all of these said? No, probably just one thing. Okay? But our goal is to get the triangles congruent, because that's the unit we're in, and then to use Cpctc to do this. Okay? So let's see how this is going to be used. So take a look at example 1. There's no picture. It's probably a little bit confusing without a picture, so we can always make one. Let's see, how is this going to look? Can't get this to be the way I want it. So we have the SM is congruent to PM, and SMW is congruent to PMW. So what do you notice that they share a lot of? M, and then over here they share what? A W. So what kind of triangle, how are we going to draw that? Don't know. Probably going to have a reflexive, isn't it? Maybe. Let's just try it out. You can always erase. So we have SM and PM. So if I drew that, what would have to be here then? Would that work? SM and M. Let's just see here. SM, PM. And then is there an SMW? And then would this be a PMW? I think that will work. Okay. Okay, so let's get your proof started. Alright, so SM is congruent to PM. Mark it. Angle SMW is congruent to angle PMW. Mark it. I'm out of givens. Even though I'm out of givens, you should know what's next. What's a freebie? Reflexive property. MW. Are those triangles congruent? Do I have enough tick marks to show the triangles are congruent? By? What? Okay, I thought I heard something else. SAS. So now see, this is where things get a little trickier, because where did this used to come from? Did you do any thinking there ever? You just pasted it, didn't you? Now and this is where easy points are taken off of the future quiz. Gotta take that time and make things match. Pick an order for the first triangle, any order. Sure, WMS. Again, we don't have to all have it as WMS. That's where my end of my grading makes it hard, because I have to now check and make sure you're doing it right. So WMS, what would WMS match then? WMP. So think about it as a trumpet going off. We're done. We made triangles congruent. I'm not a trumpet player, so I know that's horrible. But we just made the triangles congruent. That's 90% of the battle. Now that we've declared these triangles are congruent, would you agree that SW would be congruent to WP? Why? Corresponding parts of congruent triangles are congruent. Because if those triangles are congruent, then basically matching pieces have to be congruent. Well, that's a little bit too broad of a term. So corresponding parts of congruent triangles are congruent.
So just because the triangles are congruent, those lines are congruent?
Those sides are congruent. So let's just think about, if I said like these two tabletops are congruent, we somehow proved these two tabletops are congruent, then this piece that corresponds with this piece has to be congruent. And this angle over here has to be congruent to that angle because they're corresponding. So if you declare something is corresponding, or I'm sorry, if you declare that two things are congruent, then all matching pieces have to be congruent. Could you think of something else that they could have asked instead of this? They could have said what? Can you prove that angle S is congruent to angle P? Cpctc. Could you say that that top angle at W, angle SWM, is congruent to angle PWM? Cpctc. So there could have been three options that they could have asked here, because we use 3 and there's 3 left, right? We use 3 to get triangles congruent, and then there's 3 other things that aren't said. So those other 3 things could be used as Cpctc. Okay? All right, so that's your first theorem, Cpctc. Pretty easy, straightforward theorem. The next one comes from a very, when would you have learned circles the first time? Like, what is PA called? What is PA? Radius. When did you guys learn about radius for the first time? 7th grade?
Yes.
Okay, so this is a review. Okay, this piece right here is. PA in this picture is called a radius. Before that though, points A, B, and C lie on circle P. And so you call a circle by its middle letter. So since P is in the middle, we call this circle P. And then A, B, and C lie on it. PA is called a radius. So what do you call PA, PB, and PC? Radii. Good. You don't say radiuses. Okay. Well, I say that and I write it wrong. Radii is spelled Radii. Okay. All right. Well, what is this new theorem? Pretty simple. All radii of a circle are congruent. If you think about your pumpkin pie next week, Thanksgiving, if you truly find the middle piece, the middle part of the pie, and you slice it to that edge of the pie pan, those slices should be congruent, right? So, either love it or you hate pumpkin pie. I hated it until about a few years ago. Okay, so PA, PB, and PC are congruent in this picture. If we were doing a proof, you could say that on the left side, and on the right side you would say all radii are congruent. Okay? So you've learned two new things to say on the right side of a proof. Cpctc and all radii are congruent. So now let's see some practice on the back. Alright, so we have a lovely picture. Given, circle P. That's the only given I give you. Okay, so I'll put it down. Given, circle P. Tell me something you can tell me. Sure, vertical angles are congruent. Now, which pair of vertical angles do I want? That's a D, yeah. Sure, CPD is congruent to angle APB. So we're talking about these angles here and here. Vertical angles are congruent. Or even better, if two angles are vertical, then they are congruent. Okay. Think about what we want. We want to prove that AB is congruent to CD. If these triangles were congruent, would they be congruent? Do you agree with that? If these two triangles were congruent, could we say that AB is congruent to CD? Why? I just told you on the front. Cpctc. So let's just think. Now, if you don't like to write stuff down because you don't want to have gaps in your proof, because like on that quiz yesterday, remember I gave you too many blanks? So I know that makes some of you guys hate that. But just think, this line right here is going to be Cpctc, right? Step 5. Step 4 is going to be that my triangles are congruent by, I don't know, SSS, SAS, something. So we just got one more thing to say. What did I just give you? A theorem, Ari? Okay. I agree that AP and PD would be congruent because what are PA and PD? Radii. Well, what's PC and PB? So really, they're all congruent to each other. All of these sides are actually going to be congruent to each other. So if this was 5 inches, they're all 5 inches. Typically, we don't see that. Usually, we have pairs, but we actually have quadruplets here. So PA is congruent to PB, which is also congruent to PC, which is also congruent to PD. All radii are congruent. Look at your triangles. Do we have enough to state that the triangles are congruent by tick marks? By SAS. Triangle, pick an order for the first. I didn't hear. CPD, sure. CPD. Now, we honestly on this picture, we don't know if this top triangle was reflected or rotated, do we? Because I don't have tick marks that are specific. So as long as one letter matches, the other letters really don't matter. Which letter has to match? P. So I don't care if you want to say CPD with BPA or APB. I don't matter. I'm just going to do APB. Now, the way I have it now means that this was reflected. So C would match A. Okay? But again, it wouldn't matter if you thought, oh, I thought it spun, so I thought C and B would match. Because we really don't know. Now, we've just declared triangles are congruent. There's the trumpet. Okay? The triangles are congruent. So, can we now say that this side is congruent to this side? By corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. Try to say that, but write Cpctc. Just like I hope you think S. You don't say SAS. I hope you're thinking side angle side when you're writing SAS. Okay. So otherwise, what's the purpose of just memorizing letters? All right. Let's take a look at the last one. Given circle O. If I give you a circle, you probably can already predict it's going to be radii somewhere in that picture or in that group. However, you might not know how to use it on a picture that's a little bit more complex like that. Do you see any radii in that picture that's useful? Make sure I'm doing it right. Say it again.
OT.
Yeah, OT and OS. Now, is there another radii in there? Okay, right? And OPR? But what do you notice about those two? They're more than the triangle, right? And so unless I'm going to use subtraction property in this, which you might see every once in a while, but see, I don't give you anything that would clue me in that there's going to be a subtraction property. So I really probably right now don't want to say anything about OK and OR. And then if I want to later on, add it in there. Putting it in here right now isn't bad, but it's kind of like overkill. If I would say OT, OS, OK, and OR, it's a little bit overkill to say all that because I'm not needing it. So mark it that those two radii are congruent. All right, anything else you see maybe that would be helpful before we go to the next given? Or we can do the next given, it doesn't matter. Next given, sure. All right, angle T is complement to angle MOT. What the heck, we haven't seen that for a long time. What's that mean? T is complementary to MOT, what's that mean? They make 90. So we're saying that whatever T is, MOT will make 90 with it. Well, that makes sense because if this would be 90, which it kind of looks like it is, 90 plus 90 would be 180, which is what a triangle is. I don't know that that's 90, but you know, it probably is. So T and MOT would make 90, okay. S and POS would make 90, we say as well. What do you think? kind of stuck right now. Yeah.
Then should do vertical angles.
Yeah, I'd probably do vertical angles. And I was kind of cluing you in on that after we did step 2. I said, is there anything you want to say before we're doing the next given? And you guys said go on, so we went on. That's fine. So what's my vertical angles? Angle MOT and what? POS? Is that safe? Ah, you should see something now.
Number 5 says VOT.
Vertical angles are congruent. VERT. It does look like an O, doesn't it? What about MO and OP? I mean, they look congruent, but that's what we want to prove. You should see something. Look at steps 3, 4, and 5. I'm going to mark my vertical angles. I forgot to do that. Look what we have. We have an S, we have an A. These 3, because we didn't use these yet for any tick marks, did we? We wrote them and we didn't do anything about them. These 2, we should be able to come up with a tick mark. And it's probably because of something here too. Yeah. Yes. Okay. We haven't necessarily seen this, or if we did, it's been a long time ago. Look at what we have here. MOT, MOT. Angle POS, angle POS. We just said that they were congruent. So aren't they the same? If these 2 are literally the same, and that is complementary to that, and that's complementary to that, but these are the same, then won't those have to be congruent? It's kind of like a weird complementary transitive mix, okay? Here's the theorem. And I don't know if you've ever actually written this down, so here it is. If 2 angles are complementary to congruent angles, then they are congruent. If 2 angles are complementary to congruent angles, then they are congruent. Well, guess what? You can take the word complementary out and put the word supplementary in. So there's 2 theorems kind of there. And I think we had this theorem in our book, that 1 unit, but I don't think you had to come up with it. I think it was a given and a proof already. Okay? And you should kind of see it. If 2 angles, here they are, T and S, are complementary to congruent angles, then they are congruent. Alright, so put tick marks on your picture. We're almost done. Angle T up here is congruent to angle S down here. Your tick marks, does it show anything? Triangles are congruent. Pick an order for the first triangle. TOM, sure. What matches T? S, what matches O? And then P. Triangles are congruent. Da, da, da. So now what? Are those corresponding? Always make sure of that. Are those going to be corresponding pieces? Yep. So corresponding parts of congruent triangles are congruent.